Okay, good morning class. So today we're looking at exponents. The examples for exercise 2.6. Okay, so we're looking at exponential expressions. Let's see what the heading is there. Simplifying exponential expressions using factorization. Okay. So when simplifying expressions in exponential notation, where addition and subtraction are used, you cannot simplify, use one of the laws of exponents. Factorization allows you to simplify the expression. To factorize, you need to be able to reverse your basic exponential laws. You may also need to factorize numerical bases to simplify it further. Okay. So I'm looking at the example, and this example is on page 49. And this is examples for exercise 2.6 on page 50. So the question says simplify and factorize, or factorize and simplify. Right, so what we do is we know that 3 to the x times 3 to the 1 is equal to 3 to the x plus 1. Not so? So the reverse is also true. If I got 3 to the x plus 3 to the 1, this can be written as 3 to the x times 3 to the 1. You guys understand? So looking at this here, I'm going to break that up. So it will be 3 to the x plus 3 to the x times 3 to the 1. Why do I do that? So that you can take out a common factor. Nice. And what is common here? 3 to the x. If I take 3 to the x out, what am I left with? 1 plus 3. Because 3 times x, 3 to the x times 1 is 3x. 3x times 3 is going to be 3x times 3 or 3 to the x plus 1. You guys understand? So, looking at the bracket, are the like terms? So, it will be 3 to the x times 4. Which also can be written as 4 times 3 to the x. Okay. Let's look at the next one. Here we have m to the exponent 3 minus n to the exponent 4 over m to the exponent 3. In the numerator, what do we notice? The common factor of m cubed. What are we left with after we factorize m cubed in the numerator? 1 minus m over m cubed. Now what? Cancel. What cancels? M cubed. So what are we left with? 1 minus. You guys understand?
Yes.
Right. Okay, so this is the next sum. It was on page 50, correct? What's on 49? Okay. Again, the answer to simplify, got 7 times 2 to the x minus 3 times 2 to the x plus 1 over 2 to the x minus 2 to the x minus 1. Okay, so what do we have to do first? Break up so that I can factorize. Can you see that, people? So if I break that up, what do I get? I get 7 times 2 to the x minus 3 times 2 to the x times 2 to the 1 over 2 to the x minus 2 to the x times 2 to the negative 1. What do you notice now? Okay, so what do we get as a common factor on top? 2 to the x. So if I take out 2 to the x, what am I left with? 7 minus, take it out, I'm left with 3 times 2. You see that, people? You guys confused? What are you confused about? Everything. Did you watch the video?
Yes.
How can you be confused about everything? Okay, listen. If this was a y, if it's 7y minus 3 times y times 2, what? Take out the common factor, what would you have? Y is into 7 minus the same. Because if I replace 2 to the x with a y, can you see it? So that will be 7 times y. If I replace that with a y, it's 3 times y times 2. So if I take out y as a common factor, what are we left with? 7. Take that out, I'm left with 3 times 2. If you have x minus x times 2 to the minus 1, what is common here? X. But take x out, what am I left with? 1 minus 2 to the negative 1. You understand that? So, if I look here in the denominator, if I take out 2x as a common factor, what are we left with? 1 minus 2 to the negative 1. So I don't understand what you're confused about. This 2 here? From here. From here. Remember that if you got 2 to the x plus 1, let's just take this 1 back quickly. If you have 2 to the x times 2 to the 1, what would that be? That girl at the back, yes? 2 to the? So that's your problem. You don't understand the basic laws of exponents. Okay? This is basic grade 8 and 9 exponents. When we're multiplying and bases are the same, we add the exponents. So that is your problem. Your problem is not where we're at now. You understand? So what I did was I said, okay, if I got 2 to the x plus 1, it can of course be written as 2 to the x times 2 to the 1. You understand? If I got 2 to the x times 2 to the minus 1, what would that be? 2 to the x minus 1. So what I'm saying in the reverse is 2 to the x minus 1 can of course be written as 2 to the x times 2 to the negative 1. That's all I'm saying. I'm using the exponential equation in the reverse. The exponential laws in the reverse. So let's try again. The links to the full lessons can be found in the description box below. Okay. So it's 7 times 2 to the x minus 3 times 2 to the x times 2 to the 1. I broke up that in the numerator. Over 2 to the x minus 2 to the x times 2 to the negative 1. Okay. So what is now common in the numerator? 2 to the x. What are we left with? 7 minus 3 times 2. to the 1, which is 2. Over 2 to the x is common. What are we left with? 1 minus 2 to the minus 1. What do you notice now? 2x cancel. Now you can do this without the calculator, which is going to be 7 minus 6 over 1 and minus half, which is 1 over half, which is 2. Or you can plug that into the calculator. So it's 7 minus 3 times 2 over 1 minus 2 to the negative 1. Gives you an answer. Okay. But confusing. Yes?
Should I get like 2 out as the common factor?
2.
Yes, out for the numerator.
For the numerator, yes?
So now if you have to multiply that 2 with the 2 inside of the bracket.
Yes. So you're asking what's going to happen if you multiply it in again? You don't see it. So it's going to be 2x into 7 minus 3 times 2. When you do that, so what is 2 to the x times 7? 14. What is 2 to the x times 7? 7 times 2 to the x. Why is it not 14? Because of that exponent there. Not the O, it's a x. Okay. It's because of that x there. That's why you can't add. Minus. So if you multiply this with this, it will be 3 times 2 times 2 to the x. Can you see that? And that bases are the same. If bases are the same, what do you do to the exponents? You add it. So it's 2 to the x plus, which gives me again what I have there on top. Understand? It comes again down to the fact that you guys are not solid in the rules of exponents. That is why. That is why you don't see what's happening. You are confused. Okay, because of that. You guys must learn your rules of exponents, please. It's coming in your upcoming cycle test. It's worth 15 marks. Okay. People, let's look at the next one. We got 3 to the n raised to the exponent 2 plus 3 to the 2n minus 1 is all over 3 to the n. Where do I start? Multiply the exponent. So what do we get? 3 to the 2n time plus. What's going to happen here? Break up. So it's 2 to the n time, 3 to the 2n times over 3 to the n. Now what do we do? The common factor. The common factor of 3 to the 2n. Can you see 3 to the 2n is common? So what am I left with? 1 plus negative 1. And this is all over 3 to the n. Can this cancel? No. When we're dividing and bases are the same, subtract. So in other words, this will be 3 to the 2n minus n. As you can see, these bases are the same. And I'm dividing. Can you see that? Times 3 to the negative 1. It's 1 over 3. Not so? So it's 1 plus 1 over 3. And what is 1 plus 1 over 3? 1 and a third, which is 4 over 3. So that's going to be 4 over 3 times 3 to the 2n minus n is? Okay, you can write it like that. Or that you will get full marks for. Or when we say dividing and bases are the same, we subtract the exponents. Either one of the two, you're going to get the full mark. Let's look at the last one. And it's on page 50. Why are you guys talking? Sorry? About the homework? You mustn't talk now. You're causing chaos, Michael. When you talk, then everybody else will also talk. Alright, so on page 50, we are asked to simplify. You got 3 to the x minus 2 plus 3 to the x minus 1 over 3 to the x plus 3 to the x plus 1. What do we do first? Break up so that we can factorize. You break that one up, that and this. So 3 to the 2x can be broken up into 3 to the x times negative 2 plus 3 to the x times over 3 to the x plus 3 to the x times. Now what? And a common factor. A common factor of 3 to the x. You see that? So it's 3 to the x into 3 to the negative 2 plus 3 to the negative 1 over 3x into 1 plus 3. You see that, people? Yeah, I took out 3 to the x, I took out the whole term. Whenever you take out the whole term, you are left with 1. Okay. So what do we notice? What can be done now? Cancel 3 to the x. Again, we can plug this into the calculator. Okay? Because from this point to your answer is 1 more. Okay? But for those of you who wants to work it out, so it's 1 over 9 plus 1 over 3 over 1 plus 3 is 4. So there's going to be an LCM of 9. So it's 1 plus 3 divided by 4, which is multiplied by 1 over 4. So that's 4 minus, cancel that 4, leaves you with 1 over 9. But as I said, you're going to plug it in the calculator. It's going to be 3 to the negative 2 plus 3 to the negative 1 over 4. It's 1 over 9. Okay. Guys understand? Okay. With that, you should be able to do exercise 2.6. Okay.